I want to talk briefly about fluid balance. So, as you know, fluid in the body is categorized as being inside of cells, the intracellular fluid, and outside of cells, the extracellular fluid. And then the extracellular fluid has two main compartments. We have blood, and there's actually only 3 liters of plasma in the average person, and 2 liters of cells, mostly red blood cells. And then there's also interstitial fluid, 11.5 liters, and I forgot to mention the number in the ICF, which is about 23 liters. So that brings us to about 37.5 liters of fluid in the average person. Now, when we look at fluid balance, we will look later at how blood pressure is generated with preload, and also contractility and afterload. That preload corresponds with the venous blood pool. So if we want to maintain a good fluid balance in the operative patients, they have a perhaps reduced circulating volume because they have fasted, so we tend to always give IV fluids to them. So what actually happens though with those IV fluids? Do they all just go into the blood plasma because we go IV, or do they evenly distribute over the plasma, interstitial fluid, and maybe the ICF? So I've given here an example of crystalloids, and crystalloids are things as normal saline, but also Hartmann's and Plasma-Lyte. So in our hospital we tend to give Hartmann's, but I also worked up to the Sunshine Coast where we used to give Plasma-Lyte. So 1 liter of Hartmann's or Plasma-Lyte contributes about 80 to 200 mils over half an hour into plasma. The other fluid goes into interstitially and perhaps even a little bit in the intracellular fluid. Okay, so that's quite surprising if you've never looked at that. So you think you give a liter of fluid, but actually 80 to 200 mils of that stays in blood circulation. The remainder goes into your tissues. That's why you don't want to overload with IV fluids, because basically you create edema. Edema in your lungs, called pulmonary edema, ankle edema, pitting edema around the ankles. Yeah, it's also very common. All right, now we have some so-called volume expanders that can be given IV. Gelofuscin, Volivan is no longer on our shelves. I think it was affecting people's kidneys too much, but I have to verify that with you later. But gelofuscin, it's like a jelly, and what that does, it actually draws fluid from the interstitial area into the blood plasma. Yeah, so it does about 650 to 850 mils. So it really expands the circulating volume, but you can see Gelo, which it comes in 500 ml bags, will add a substantial amount of volume to the plasma. Now then there's this other product which is made out of human blood, and it's one of the most important, or present in large quantities in blood as a protein, is albumin, and it comes as Albumax. So you can 20 grams in 100 mils becomes Albumax 20, or if that similar amount is diluted in 500 mils, it's then called Albumax 4. So my camera was focusing a little bit on the kidneys before here. So the kidneys are an amazing organ. 25% of your circulating volume is filtered at all times in your kidneys. So per minute it means 1.25 liters are filtered. And of course kidneys make urine, and if we measure hourly urine output, gives us a good idea how happy those kidneys are producing the urine And the formula that I always was taught was 0.5 mils per kilogram per hour. If you're really worried about the kidneys, you can do some blood tests as well. You can see the glomerular filtration rate, but particularly you can look at waste products like urea and creatinine to see if they are excreted, yes or no. So overall, that's fluid balance. Yep.